G'day, Year 9. Today, we're continuing our unit on trigonometry by looking at angles of elevation and angles of depression. Okay, now elevation just means going up, and depression just means going down. And what these angles are is they're the angle created with a sort of imaginary horizontal line, and either starting from the horizontal and going up, or starting from the horizontal and going down. Okay, so basically depends on your perspective. If you are underneath something and you're looking up at it, then that angle between the horizontal and you and the angle you're looking up is an angle of elevation. If you are on top of something, above something, and you're looking down towards it, then that angle between the horizontal and the angle that you're looking down is the angle of depression. So you can imagine, let's say you've got this cliff face, you've got someone looking up at the cliff face. So the angle between the horizontal of their line of sight, if you will, and looking to the top of the cliff is the angle of elevation. So just in here. And the angle of depression would be the angle created with the horizontal from the top of the cliff face, then looking back down at the person. So this angle in here. And because these two horizontal lines that we create are parallel, then the angle of depression and the angle of elevation are actually always equal because they make alternate angles on parallel lines. Now, the most important thing is we don't get the angle of depression confused with this angle inside the triangle. Okay, so if you imagine a triangle made with, say, the vertical object, the horizontal, and the imaginary line between the top and the line of sight, then the angle of depression is always on the outside of that triangle. So just remember, it makes alternate lines, and that way, alternate angles, if you will, so you don't get confused with the angle that's inside that triangle there. So what we're going to do is going to do a few example questions that contain elevation or depression. We need to practice drawing diagrams. So I'm going to talk you through how to do that. And then we're going to use our diagrams to use and our trigonometry to solve the question. Okay, so here we have the angle of elevation of the top of a flagpole as observed from a point 15 meters from its base is 63 degrees. Draw a diagram and find the height of the flagpole. Okay, so we've got a flagpole here. We don't need to draw the flag or anything. We can just draw the pole. And then we've got a point that's 15 meters from its base. Okay, and we've got this imaginary line looking up at the top of the flagpole. We know that the distance between the point and the flagpole is 15 meters. We know that this flagpole is going to be at a right angle to the ground. And we know that this angle here, the angle of elevation, so horizontal up, is 63 degrees, okay? So we've put all of the information that we know in our diagram. We've drawn a flagpole, we've drawn the distance from the flagpole, we've drawn the angle of elevation from that point to the top of the flagpole. But we've got to also ask ourselves, what are we trying to find? And the question says, find the height of the flagpole. So what I'm going to do is I'm just going to put an X in the position where my unknown is that I'm trying to find, the height of the flagpole. And what we realize is we've just created a right angle triangle here with enough information for us to use trigonometry. We realize that, hang on, I've got an angle, I've got the opposite side, and I've got the adjacent side. So I'm going to use tan. So in this case, we set up our equation, tan 63 equals the opposite over the adjacent. And then I stop and I think, where is my unknown? And I realize X is on the top of the fraction. I need to times both sides by 15. So 15 times tan 63 equals X. And then I can pop that in my calculator. Okay, so 15 tan 63 equals, and then we're talking about distance here. So you've got to be careful. If you're talking about a distance, then you don't obviously want to use degrees, minutes, and seconds. If you're talking about an angle, then you might want to. But here we have our answer, 29.43. I'm going to round it to one decimal place. So X equals 29.43 dot, dot, dot. And then it approximately equals 29.4 meters. Okay, and that's to 1 decimal place. Okay, so you see, we drew our diagram, and then we used our trigonometry. You're kind of almost creating your own question in a way from the information you're given when you draw your diagram. Okay, let's give ourselves a bit more space here. We've got another question. So we've got a vertical cliff, okay, 150 meters above sea level. Okay, so here's the cliff, it's 150. Then there's a boat. Let's put the boat over here on the sea. And then we're told that the angle of depression is 50 degrees. So the angle of depression is the horizontal down like this. We've got to make sure we put that in the right place. Okay. And now we've got to find the distance of the boat, the base of the cliff. Okay, so here's the sea level, and we're trying to find this. Okay, now we've got to stop here. We've got to realize we have a problem. Okay, we have the angle of depression outside of this right angle triangle that we've created here. Now, there are multiple ways you can go around this. Okay, one way we could go around this is we could sort of create another right angle triangle, put that angle in. Another way we could do it is we could use our alternate angles, and we could say that this angle is 50 degrees as well. Another way we could do it again is that we know that this creates a right angle too, so therefore this angle on the inside of the triangle must be 40. Okay, the most important thing though is that you choose one of these ways, okay, and you don't get confused. If we put the angle on the inside of the triangle up here as 50 degrees, then we're going to get it wrong. Okay, so either choose using the right angle law or use alternate angles, because it will make a difference as to which side becomes the alternate and the adjacent, and which side becomes the opposite. So I'm going to use these alternate angle laws and put the 50 degrees down here on my diagram as well. And then I can say I've got opposite and I've got the adjacent side. So tan 50 is going to be 150 over x, and then I can cross multiply to get the unknown on its own. Okay, so I times both sides by x and I divide both sides by tan 50 and I get that. And then now I can plug that into my calculator. So 150 divided by tan 50 equals, and again, we're finding a distance. So we're just going to go to 1 decimal place. So equals 125, it was 0.86, I believe. Yep. Which becomes approximately equal to 125.9 meters to 1 decimal place. Okay, so with depression, just remember it's horizontal down, and then you might have to think about trying to find an angle inside the triangle first before you then go about using your trigonometry. Okay, finally, let's do one more example. A kite is flying at a height 45 meters above the ground on a string length of 70 meters. Find to the nearest minute the angle of elevation. So we've got our kite. Okay, our kite's up here. And then we have the person flying the kite. We have a piece of string like this. And then we've got the ground. We can draw that as a solid line. So we know that it's 45 meters above the ground. We know that the string is 70 meters. We're trying to find the angle of elevation from the ground. We're trying to find this angle in here. We're going to draw a theta in there as our unknown angle. So we notice now from our angle here, we have the opposite and the hypotenuse. So it's going to be sine of our angle equals opposite over hypotenuse. And now we can find the angle by using inverse sine. Okay, and then get our calculator up. We can go inverse sine 45 over 70. Make sure we put that bracket in the right spot. Okay, and we get our angle. They want it to the nearest minute. So I'm going to click that, and it's just 40 degrees and 0 minutes. Is going to be our angle that we're trying to find here. Okay, so good luck with that. Remember, take your time to draw the diagram. Make sure you put all of the values in the right spot. And then once you're sure that everything's in the right spot, you can start using trigonometry to solve the question, okay? There's no point rushing ahead into your trigonometry if you put the information in the wrong spot, because you're just going to get the wrong answer. So good luck with that. I'll catch you later. Have a good day.